Good afternoon, class. This is Mr. Troop coming to you live from the internet, I guess? I don't know. I'm in my classroom. It's actually not live at all. I did this last night, which is weird saying right now because I'm in the moment, so... Oh, well. Anyway, what we're going to do today is we're going to be reviewing what we talked about yesterday. We're going to be factoring this expression. Now, if I were to factor this, I know without a shout of a doubt that this is going to break into two binomials, one of which has 2x, one of which has x, because 2x times x equals 2x squared. Now let's analyze this number negative 15. And let's realize that it could break into factors such as negative 1 and 15, negative 3 and 5, the ever popular negative 5 and 3, and then of course negative 15 and 1. We just need to kind of try these out, guess and check, get a feel for which ones work. Okay, Blake, go ahead and pause this video. I want y'all to try it out. Alright, so Blake paused the video. I'm very proud of him. If he hasn't quite done it yet, everyone laugh. If he has, and we're replaying this video, let's see what we should have learned. Hopefully you guys probably tried maybe a negative 3 and a positive 5. And then you did a little bit of guess and check. 2 times 5 gave me 10x, and negative 3 times x gave me negative 3x, which when we combined gave me positive 7x. Is that what we wanted? No, of course it wasn't. So hopefully after we made that mistake, we didn't give up, and we tried something new. Okay? I'm looking at maybe trying switching these up. Make this the positive 3, and make this the negative 5. Same concept. 2 times positive 3 is going to be positive 6. Negative 5 times x is going to give me negative 5x. When we combine these terms, we should have gotten positive 1x, which is still not what we want. Holy moly, that is not good. So lastly, you should have gotten really frustrated by this point, but hopefully you didn't give up. And you realize, well, if I just did a little editing, and instead of making this positive 3, made it negative 3, and instead of making this negative 5, making it positive 5, then we can look and see. 2x times negative 3 gives you negative 6x, and 5 times x gives you positive 5x, which when we combine gives you negative x. Is that what we want? Of course it is. So, our proper factorization of this problem is 2x plus 5 times x minus 3. Are we feeling okay? Let's try another one. What if I gave you 3x squared minus 24x plus 36? Oh, these numbers are getting much larger, Mr. Troop. I'm not really digging this. I don't know what you're doing, but you're kind of messing with me. Well, one thing we are allowed to do is if we notice, wait a minute, all of these numbers are factors of 3. We could start this problem by factoring out that greatest common factor. I can divide every single person by 3, leaving me with an x squared minus an 8x plus a 12. Now, who agrees that this is a nicer looking problem? Absolutely it is. All right. Keep in mind, this 3 has to stay in the problem. Don't let it run away. It doesn't get a pass. It has to hang out with us. It has to be our friend. We see an x squared by itself now. This is amazing. It's all by itself. There's no coefficient. So I know it's an x times an x. Now let's think about this number, positive 12. Positive 12 is not too bad. It can break into numbers like 1 and 12, 3 and 4, maybe even 2 and 6. But this is what gets really interesting. I see that this number right here is negative. If I have a whole bunch of positive numbers, there's no way they're ever going to become negative. Positive 12 breaks into factors like 1 and 12, 3 and 4, 2 and 6, but it also breaks into factors like negative 1 and negative 12, negative 3 and negative 4, negative 2 and negative 6. So after looking at these, which one of these groupings is going to add up to give me negative 8? Well, it looks like negative 2 and negative 6 is going to add up to give me negative 8. Okay? So what we just saw there, class, is we can always make our problems a little simpler before we make them complex. And then we find our absolute perfect factorization. The kicker right here, guys, everyone's going to want to forget this. Do not forget the 3. Just because we factored him out doesn't mean he's not our friend. He has to follow us no matter what. All right, I got a couple more. I like this problem, x squared minus 8x plus 12, but I'm going to change it a little bit. What if I give you x to the 4th minus 8x squared plus 12? This problem looks very beefy. Like, this problem belongs at Taco Bell. It's like beefy and supreme. But that's okay. Think about this really quickly. I broke these into two binomial terms. And I'm used to saying x times x equals x squared. Well, then what times what equals x to the 4th? X squared times x squared. So if I take x squared times x squared and I multiply them together, what am I going to get? Well, x squared times x squared equals x to the 4th. This is exactly what I want. So let's work with this. Now, we know from the last problem that factors of 12 that add up, negative 1, negative 12, negative 2, negative 6, negative 3, negative 4. If we want the factors to add up to negative 8, we're looking at these two factors right here. So watch what happens. If I put a negative 2 right there and a negative 6 right there, let's check our work. I'm going to FOIL everybody. X squared times x squared gives me x to the 4th. X squared times negative 6 gives me negative 6x squared. Negative 2 times x squared gives me negative 2x squared. And negative 2 times negative 6 gives me positive 12. Well, think about these. Aren't these just like terms? Absolutely they are. Negative 6 and negative 2 gives me negative 8x squared plus 12. Do we agree that this happens to check out? Of course we do. So our factorization of this much more complicated looking trinomial factors into these two perfect binomials. Okay? Good. And hey, Blake, feel free to pause this video at any moment if I'm going too fast or you guys need to slow down. Also, Blake, I'm putting you in charge of rewinding if you guys need to go back. All right, we got another problem. I want to focus on the same kind of setup, but instead of getting x to the 4th, let's up our game a little bit and get x to the 6th minus 8x to the 3rd plus 12. This is looking extremely familiar. We've seen this problem before. It looks a little different, but I feel like we just did it. Well, if I have x to the 6th, I have to multiply two components. X and x multiplies to give me x squared. Well, how about x to the 3rd times x to the 3rd? We remember from Algebra 1, if we have two bases and two exponents, what do? We add those exponents to get x to the 6th. So yes, x to the 3rd times x to the 3rd does equal x to the 6th. You should be getting tired of hearing me say this by now, but let's talk about positive 12. Well, positive 12 breaks into negative 1 and negative 12. It also breaks into negative 3 and negative 4. And it also breaks into negative 2 and negative 6. We want to add up to become negative 8. Let's go with negative 2, negative 6. Okay? If you don't trust me, you think I'm crazy, you think I'm making stuff up, let's check the math. X cubed times x cubed gives me x to the 6. X cubed times negative 6 gives me negative 6x cubed. Negative 2 times x cubed gives me negative 2x cubed. And then lastly, negative 2 times negative 6 gives me an astounding positive 12. Add your like terms. We get x to the 6 minus 8x cubed plus 12. Does it check out? Absolutely it checks out. So my factorization is this wonderful x cubed minus 2 times x cubed minus 6. All right, guys, that's all for this video. Selma, you're starting the videos. Don't forget, go ahead and start the next one now. I look forward to seeing you guys here in about 20 seconds. All right, you guys keep doing a good job. I'm really proud of y'all. Adios.